I'm really happy to be presenting another meetup this season. We have Ravi Lachmann, who comes to us from Shippa. Shippa is a company that builds a layer on top of Kubernetes to make Kubernetes deployments easy and painless. Ravi has been an evangelist with a company called Harness. He's had sales and engineering roles at other companies, and I'll let him speak a little more about himself as he gives his talk about Shippa. So welcome, Ravi.
Yeah, thanks for having me. Excited to be here. Actually, I'm at a conference. I'm at DevOps Days Atlanta, so I gave one set of talks today. So one more to the NYC crowd. Really excited. And today we'll be talking about Kubernetes for the JavaScript developer. So just kind of a crash course on what is containerization, how, what, when, where, why Kubernetes, and how do you go about deploying on Kubernetes if you're a JavaScript developer. So dealing with one screen here. So a little bit about me. So Alim was giving me a little bit of a background. Currently, I'm the Field CTO at a company called Shippa. Prior, I was a chief architect at a continuous delivery firm called Harness, and before that, I was traumatized by Kubernetes, and I was a distributed systems engineer at Mesosphere and Red Hat, and so I built some big stuff. I learned later in my career that if it worked right the first time, it did not work. I must have gotten it wrong. And also the iteration is key, right? So how we go about building software, it's always about trial and error. And so what are we going to be talking about this evening or today? I've been talking about, well, what on earth is a container? So we'll kind of go through, well, what are some ins and outs of containerization? How did we end up with it? Where are we going with it? And then, after that, we have to introduce an orchestrator. And if you're unfamiliar with what it is, we'll talk about some core pillars of what orchestration means. And, the 800-pound gorilla, or the flavor du jour, depending on your opinion, is Kubernetes. And then also JavaScript to Kubernetes the easy way. And so the firm I work at, we really are hyper focused on developer abstraction and application abstraction. So as a developer, all I have to do is produce an image, and that's it. I'm able to deploy to Kubernetes with Shippa. So I give you a little bit of a demonstration, going from source code to build something, the kind of standard accessories, and then just deploying that onto a Kubernetes cluster. And so a container, what is that? So kind of to talk about containerization, I mean, it goes back to, changes in basic compute, right? So if you go way back in the Wayback Machine, if you remember a mainframe, right? And also x86 when you kind of got off the mainframe. But what's similar about kind of like the first two types of workloads is that they're pretty specific, right? They're pretty named, and as you kind of get towards more like virtualization and then finally this cloud native workload, they're not very machine centric, right? So a mainframe, exceptionally machine centric workload, physical or x86 types of workloads, they're exceptionally machine centric, right? And so as you start to virtualize, right, so virtual machine and even going into cloud data, and these things are not so much machine centric or more than requirement centric. You might say, from a developer standpoint, if you do any sort of load testing or benchmarking, you might say, for 100 concurrent users, you know what, I need 8 gigs of memory and, you know, 2 CPUs and maybe 50 gigabytes of durable storage. It's fair. And I don't care where on earth that is sourced from. You know, and then finally, you know, we bore into this concept called containerization, but containerization has been around for a while, right? So, you know, I would equate it to these Tupperware little things here. But let's talk about exactly what is containerization, right? So, if you take a look at if you compare something against a virtual machine, right? So, like, let's say an Amazon EC2 instance, or maybe some sort of, if you're using vSphere or like VMware, like, let's compare what a VM is to a container. So basically, at a high level, a container is exactly what you need with an asterisk. You know, there's different types of base images and whatnot, but a container is exactly what you need to run the code, right? And so that can be the library dependencies and things that those libraries need to run themselves. So like the transitive dependencies that you need to run something. For example, you definitely need some, you know, pieces of the operating system to run something, but most of that is shared on the containerization. Like, kind of the core pillars of a container, they're a little bit, they're lighter weight than a virtual machine. You know, they have things that are they're very quick to start up, and also they're very quick to stop, right? So containers are designed to die, so they start up quickly. Minus like the, you know, with the asterisk, your application that goes in, not, you know, your application will start up at the same time. You know, in a virtual machine, you're not going to get any performance or cold start times in a container, but, you know, you're at least the init before it starts starting, it's quicker. And also for density, right? Like, you know, a virtual machine is an apartment, you know, if a physical machine is a single family home, a container is a hotel room, which ironically I'm staying in right now for an event here in Atlanta. And so if when you say container, right, like, you know, the first thing that folks might reach for is Docker, right? So Docker is a very popular container format, but there was a lot of precursors to Docker. Docker absolutely was not the first container format that was out there. I mean, a going joke, you know, when I heard of Docker in 2014, I thought it was cargo power pants, right? I'm like, oh, I go to Kohl's and buy Docker. Well, my running joke, but you know, it gets its lineage from Solaris zones, right? If anybody remembers that, and also the format that, you know, kind of heavily influenced Docker, LXC, Linux containers. That was a ratified format in 2008, right? And also notable mention the container wars that are no longer, you know, very popular. Actually, a firm I used to work for, Mesosphere, they had a Meso-C was a container format, and also something like RKT, which is a Rocket, which is another container format. So kind of taking in the best little pieces of these particular formats. Docker, you know, kind of rose. And the kind of the key notion of Docker is that it has an ecosystem. And so there's Docker Hub, right? There's ways of injecting dependencies, there's layering. And so, like, from a developer standpoint, it's easy to consume. And so let's talk about, okay, the kind of the next step after we get, you know, the image out of the way. Like, okay, you know what, we need to create an image, you know, we want to have parity between environments. So we're creating an image, you know, all the, you know, the hype that's there, but, you know, there's a need for orchestration. And let's talk a little bit about how Kubernetes came to be. So the first thing is that Kubernetes is fairly new, right? Like, well, you know, in 2022, it's not novel to run Kubernetes anymore, but it's interesting to think about it that Kubernetes is only kind of 8 years old, right? And kind of the influences of Kubernetes. They're the large web scale folks, at Google or Facebook or Microsoft. They had very sophisticated workload schedulers to run their particular infrastructure. So that would be Facebook Tupperware, Google Borg, and Microsoft Apollo are 3 of those systems. They will never open source those till the day the company falls down, right? Those are core to how they do business, and they'll never open source it. But as they were looking to, kind of get additional, let's say, eyes on it and produce a different way of doing work, Kubernetes hit GitHub in June of 2014. And then finally, I think the last release, actually 1.2.4 just came out. So as of right now, it's the 24th release of Kubernetes at 8 years in. And so it's still, it's gaining traction. Imagine using a virtual machine in 8 years before 2014 and 2006. Wasn't that novel of a thing at that time. So also let's talk about what ends up happening, right? So let's take Kubernetes out of the picture. So if you're building any sort of application or any sort of distributed application, I call it service on service on service. This is actually a trace diagram, right? So if you take this eye chart, as a child, you'd stare at something and a pirate ship would pop out. That's how I would equate, this dependency or call trace diagram to. But what ends up happening, it's very easy to spin up a container. You're like, okay, I need to make something to produce some work. I need to put it in a container. But what ends up happening is you have lots and lots and lots of these little endpoints, right? Oh, I have a widget that calculates the weather. I have a widget that tells me my shipping cost. I have a widget that validates my FIPS, my fully qualified zip code. And it goes on and on and on. You can decompose, functionality like that. But you start gaining a lot of services. And so it's easy, if you're on your local machine, right? I'll actually build a Docker image here. It's fairly easy to run one, but as you increase the number of services, there needs to be a couple of things in place for you. And so, what ends up happening, there's this the design construct called a big ball of mud. It's from the microservices manifesto. Bob Fowler kind of came up with this. I mean, I was trying to find a ball of mud photo here. But basically, hey, your services will continue to grow, right? Even if you create new services, it kind of surrounds outer services. These type of design patterns and paradigms are, kind of, it doesn't matter what you're using, right? It's going to happen. If you're using Kubernetes, again, another one of my asterisks, you can still design this big ball of mud by accident, just depending on how you orchestrate and design the services. One of the things that Kubernetes will be helping on is at least there's some sort of standard way to kind of keep track of it. So the last, one of the last jokes that I have here is that container sprawl is the new VM sprawl, right? And so it's easier to spin these up. If you remember, spinning something up, instead of taking minutes, could take, seconds, right? Or not thousands of milliseconds, but as it's easier to spin up, you'll inherently have more of them. And so, how do you keep track of what's running? Even more so, what happens when something dies, right? Because containers are, by nature, it's ephemeral. Ephemeral means short-lived. And so also two words that, as an adult, I had to learn later in life was ephemeral and idempotent, or dipendent. So it's containers are meant to die and also they're not meant to change, right? That's the idempotency portion of it. I had to learn this word a couple of years ago. It's odd as an adult to hear a word that you don't know, right? So, but basically to kind of smooth over that container sprawl and how do you try to line stuff up. The container orchestrators came about, right? And so how do you, and I'll talk about what are some pillars of orchestrators, but they to the public, if you're just kind of looking back over the last 10 years, popular orchestrators would be Apache Marathon, so that predates Kubernetes, Docker Swarm, that was from the Docker organization, and also the 800-pound gorilla today is Kubernetes, right? So making sure that your ship doesn't tip over. How do you have a particular way to have a couple pieces of functionality? So let me talk about core pillars of functionality of a container orchestrator, right? So as we're going along with our journey here, the first thing is resource management, right? And so now resource management happens to be like, okay, how do I go? And this ties hand in hand with scheduling, right? So resource management would be, I have a particular pool of resources that I have. I need to place certain, let's say, containers that require certain resources. How do I make sure that, given, let's say I have, Kubernetes is node based, so I have, let's say in my pool, I have 2 worker nodes, each has 8 gigs of memory. How do I go and place that piece of workload that was like, okay, I have a need for 4 gigabytes. Where these 2 nodes memory? Where do I go place them? And that would be the resource management piece of it, right? The more interesting piece, though, like, okay, we get what resource management is. The more interesting piece is the scheduler, which is the enforcer of the resource management. So one of the most difficult things to do, let's say, is scheduling. And so what does that mean? So let's say I have, Kubernetes is a declarative based system. So you might say, hey, I need 2 replicas. I need 2 running instances of something. And to the schedulers, the best of the scheduler's ability, it will fulfill your request to schedule something. Oh, I need 2 of something somewhere matching these particular requirements, right? So imagine you're trying to find an apartment in New York, you don't pay that fee, but you need to find a realtor. It's like, hey, I need a washer and dryer unit. I lived in New York for a little bit. That was my core requirement, and an elevator. I'd have to make a walk upstairs these days, and not many stairs, so schedule is the same thing, right? I need to do something. And also, if there's deviation, let's say a container or a pod, another Kubernetes term there, died, the scheduler will roll back around and try to reinforce the state, saying, oh, there was a request for 2, 1 is the current state, let us get to 2. And that's basically, I would say, the harder piece, of the Kubernetes equation. So let's talk about now, let's get into a little bit of what we came here to see. So JavaScript to Kubernetes, right? And so, like, let's say you were starting out fresh, like you were able to maybe build a Node.js application. So there are a few pieces here, and so there's lots of ways to get Kubernetes these days. Like it's not, it's, you know, it's like, it's not unusual to run into a Kubernetes cluster. Or if you never spun one up, there's lots of ways. There's ways that are prudent to your laptop, right? So to your local machine. There are projects like K3D or K3S, and also Minikube, that you're able to, you know, run a few commands and get a, you know, a one node cluster with Minikube or a multi-node cluster with K3D on your local machine, given, you know, your constraints to your machine. If that's, you know, even that could be a little difficult depending on, you know, some of the networking constructs that are there, right? Like, you know, oh, how do I get at tunneling? Do I need to tunnel something? Can I make, you know, what's the word I'm looking for? Yeah, tunnel is the right word. How do I get connectivity from my local machine to Kubernetes? Like my biggest challenge with Kubernetes, I've been using it for years, is always networking related. Like, how do I get access to my workload? Like, is it a private IP, public IP? Is it on the daemon? Is it on the worker node? Is it goes to the Kubernetes API? Is it on the, you know, the main or master node? It's a little bit difficult. So like there's other ways to spin stuff up. You can use a purpose-built cloud. I'm actually, in my example, I'm using Civo Cloud. So Civo is a purpose-built Kubernetes cloud vendor that you can spin up clusters like that and have, you know, networking that makes a little more sense. You get an IP and stuff like that, that's publicly accessible. And also like the big cloud vendors, you know, let it be Amazon EKS, Google GKE, Azure AKS. The list goes on and on. There's lots of ways to grab a cluster. So the first piece would be, you know, grabbing a cluster, and I can show you what spinning one up looks like. The second piece is okay. It's like once you have, you know, Kubernetes up and running now, like clearly if you have it on your local machine, you know, you would have to have like Docker or HyperKit or something running to power Kubernetes. But the second thing would be on your local machine. Hey, you know what? Go ahead and grab a Docker runtime and go ahead and run and get kubectl. Actually, there's an entire talk today at DevOps Days that will have about how to pronounce kubectl, this kubectl. I say kubectl personally. But you can install, you can run through this with like brew, right? So homebrew. The first thing you want to do is like, oh, let me go ahead and install the Kubernetes CLI. And then the next step would be, okay, I want to install Docker. And then with those two pieces that you have, we can actually go through things. Also, what would be helpful, especially if you're building Docker images for the first time, you know, it'd be helpful to publish them somewhere, right? So this is going back to like why Docker is such a popular format. If you don't have a Docker Hub account, they're free, right? So you can like push images that you build up for free to Docker Hub. I mean, also like if you know, cloud vendor wise, you could be using something like Amazon ECRs or Elastic Container Registry. That list goes on and on for cloud vendors. It's you know, kind of table stakes to do that. And then once you get those two pieces, building something should be pretty straightforward. So now I'll be showing kind of my example that I have, right? So, you know, I have an oversimplified project here, but if you want to follow along with me, feel free. So I have this particular address here. So it's I'll post it in the chat for everybody. I'll be kind here. So if you want to clone this project here, I have one monitor, so I have to like pause the my, my screen sharing. Let's see. So kind of give that project I'll move my chat over here so I can keep chatting with people. If anyone has questions, go ahead. You can clone this project. You can run, get clone, or you can just, even if you're not familiar with it, you can right click, download zip. And it's a pretty straightforward project, right? Like it has a node file, it has a Docker file. So this one is like really rudimentary. If you've never seen a Docker file, it's kind of like the manifest or recipe that Docker will use to kind of interpret and say, oh, okay, like I need to build something from somewhere. What is kind of like the root directory for me to mount something? And also, is there any other like file operations that need to happen? And then what, the kind of the more important parts, it's the last two are like the most important pieces, like from a developer standpoint, like what is my first command that I need to run? Node.js, Node, running the server command. And also like what port do you want to expose if you manage for traffic, and you can kind of bundle that together. And then also in my example, I work for a place called Shippa. You can sign up for Shipa Cloud. So if you want to grab a free account with us, Shippa is a developer platform. So I'll kind of walk you through. I already have an account. I work here. Hopefully I do. If I don't have an account, right? Like, and I'll kind of walk you through an example. So let me go and do that kind of like soup to nuts, as they would say. So let me jump out of presentation form. Again, if you have any questions, feel free to chat. Also, if you want to come off mute, love the live questions too. So we could talk about anything also, seen a lot of Kubernetes in my day, unfortunately. And so let me pull up. This is the beautiful East River, and Jersey's on the other side. If you've not seen it, you have the wrong view, right? So kind of the first thing that, actually I'll start with the JavaScript. So move this out of the and so here's a sample project that I have, right? And so the easy no Docker, we'll start with the source code, right? And so a very, very simple thing, I have this really like goofy thing that this, says hello Kubernetes. And also, the Docker file, which is the all important kind of recipe or manifest what I would be using to build something. And so once you kind of clone the project down, and let me just grab it real quick. Pause my screen, get to the right folder. And a sec here. So I have, some of it's going to be like easy bake magic, from the TV cooking file, but here I have my particular my particular stuff kind of pulled down, right? So once you have some source code, you can definitely build something. So I cheat and have all of my commands here, but it's not that many commands. So we'll start with Docker, right? And so if I come into the kind of root of the folder here, let me blow this up too so folks can see a little bit better. So hopefully that's a little bit more easy to read there. This is, this I have downloaded on my machine. I have actually Docker desktop running, so I cheated and used Docker desktop. Just be words of the wise, you depending on where you work, the Docker Marantis purchase. There's pretty strict limitations with like number of people. Like I work for, an 18-person startup, so I'm well under the number of, if you have more than 250 people working with you, you have to pay for Docker desktop. But there's you can use a Docker engine that's running. So first thing is I want to make sure Docker's running. So good. Docker is running. There's no running containers on my machine, right? And so here I have my particular stuff that I've downloaded. The kind of like the next step here would be to do a build. And so let's dissect this command here. And so Docker works on a series, or when you build something, a tag is extremely important, right? So a tag is basically, an identifier of what you're building, and it's kind of like the geolocation or coordinates for what you need. And so I have a Docker Hub account that I have several images that I have built here, but I'm going to be pushing into sample.js, right? So this is going to be the location that I'm pushing into. We can take a look at, I'm building a tag to go there. So Ravi Lachhman is my account name. Sample.js is the image name. And then after the colon, that's a tag. So that's a version, right? So let me go ahead and, let me increment this a little bit. So let me make version 1.03. And this might take a second, just depending on how fast my internet at the hotel is. So actually, that was pretty quick because it actually, part of the benefit of using Docker is caching. I built a version, yesterday before this kind of speed some stuff up. But then that's getting built. So after you have your image built, right? And so like, hey, this is like, okay, as a JavaScript developer, I can execute this command on my machine. That's perfectly fine. But kind of the next step would be like, okay, like, how do I start getting this stuff out into the wild, right? And so with that, we're going to do another native Docker command here, is that we're going to do a Docker push. And so basically this is, Docker, like the Docker client is pre-wired to Docker Hub. Now I did authenticate ahead of time, but let me go ahead and run this. So I'm going to be running a particular Docker push. I want to push the version that we just built, which is 1.03. And let's see how fast hotel Wi-Fi is. So again, Docker cached, the layers here. It knew that nothing, based on SHAs, like nothing has changed. And so let's see if it went up. And so we come back. If we come back to Docker Hub, hopefully a new tag is available to refresh. And here we go. So version 1.03 is there, but it's the same SHA 95 hash that it is. So we'll say, oh, it's nothing has changed. So good. Okay, now I have an image, right? So how do I go and see hello Kubernetes on my screen? And so this is where Shippa will come in. But the first thing you need is a Kubernetes cluster. And so I don't work for Shipa Cloud, but I have a Kubernetes cluster running in Sivo. It's actually, if you haven't used any sort of cloud Kubernetes before, it's extremely easy to use Sivo. I think it's the easiest, to start up. I mean, I can come here, if it doesn't want me to log back in, and I can basically say, I would like to spin up a new Kubernetes cluster. And I can basically give it some proportions, like, this is like, the meetup. And that's pretty much it. I mean, just give it a size and it will spin up like that. I have one that's running currently. And so let's get back to it. I called it JS that we have here. Just one of yesterday, just ahead of time. And so kind of like the next thing that you need. So if you have not heard of kubectl, that kubectl is your main command line into Kubernetes. It's your gateway into it. So excuse me. So there are a few ways to so the main thing with Kubernetes or kubectl, there's something called a kubeconfig. So it's basically like a configuration file telling the client, which is kubectl, how, when, where, and why to connect to a Kubernetes cluster, right? So you dissect them on, there's your private key, there's CMDs if it's like, requires another another command in your machine. For example, if I spun up an Amazon EKS cluster, the CMD would be AWS because it needs to authenticate with IAM before it connects out, right? So like it goes on and on and on. But with Sivo, it's fairly straightforward. Actually, I have the command here. I do with Shipa Cloud. I can basically run a command and it will inject for me. Actually, I will run it one more time. Let's just show folks what it says. It will inject the kubeconfig with me. And so I'll have to double check if it works. So one of the first kubectl commands you can run is kubectl get node. And basically it will say, here we go. It's able to connect to my Kubernetes cluster. Like Kubernetes is object-based. So, basically, kind of Kubernetes 101, everything's an object or a resource. So you can get them, describe them. They have a dot nomenclature. So you can give like a qualified class name, like, hey, I want to talk to, like some star like crossplane or something class name / object name, and it will display that. So that's my 2 minute clicks in for the class today. But so we have a Kubernetes cluster that's awaiting. We've pushed an image into our Docker hub. And now it is time for us to deploy something. So how do you go about doing that, right? So Kubernetes is a YAML monster, so yet another markup language. If you've ever dealt with Kubernetes before, you'll be dealing with lots and lots and lots of YAML. YAML, it's a configuration format, and it can be fairly lengthy. Like Kubernetes, everything in Kubernetes you have to kind of be a little bit explicit on what you need. But kind of showing some of the magic that we have here at Shippa. Let me go ahead and start, kind of. So let's say that you already had a particular cluster that you have. So when you sign up for Shippa, you come to Shippa for the first time, you log in, you see Shippa, and this is where some of the developer platform part of Shippa, and it'll be super quick for us to deploy. Kind of the first thing is with Shippa, is that we have this abstraction framework. And so I already created one ahead of time to kind of spare you from it. But if we can take a look at a framework, it's basically, if you come and take a look at a particular framework that we have here, a framework is basically a 9-pronged English approach of what you need, right? So instead of going and authoring the YAML exactly what you need, you're basically, Shippa will author the YAML for you, and also the needed Kubernetes objects. So for example, we want to expose networking. Well, you have to, in Kubernetes land, you have to go about and chat with something called English controller, and configuring your English controller, you need something called CRD, a custom resource definition. And so it goes on and on and on. Like there's objects on objects and objects and YAML and YAML and YAML. So basically, Shippa will kind of like, hey, prompt you through like, hey, for this type of application, blah, blah, blah. But I created one by default. This is only two clicks here. So let's go ahead and do a few things. So the first thing that Shippa needs is actually access to the cluster. And so to create a framework, we'll go ahead and add a new cluster. And so for that, I can come back to Sivo and I can say that, okay, my API endpoint is this. So this is the master node of Kubernetes. Your way into the cluster always starts with something like this, right? And so let me go ahead and add that cluster. And so I will call it, and hopefully I'll generate the command here. So all I have to do is copy and paste this command. And so let me go ahead and paste that in. And with that pasted in, it should be binding the cluster. So we can see the Shippa stuff coming up. And so this will take a minute, right? Like I actually have one that's awaiting. So as this one will kind of come and bind itself, that's fine. So as this stuff kind of comes up, basically what Shippa is doing in the background is configuring a few things for you, right? So Shippa, the background is inserting a bunch of, let's say, monitoring centric items to monitor your workload. It's also configuring first, even things that are like non-sexy, right? Like how do I, get a certificate or SSL, I do HTTPS on my workload. How does that play into Kubernetes? Like Shippa is installing Cert Manager and Let's Encrypt for you on the back end here on your cluster, and that's getting bound. And so that stuff will be starting momentarily. Let's go ahead and not launch that anymore, but that will be setting up. So I'll go ahead and just deploy really quickly as the cluster kind of comes back up. I will go ahead and add a particular framework back to this cluster here. Can I? Oh. It is in use. Did I cheat? Oh, it is on there already, so I will drop that. So let me go ahead and just deploy an application really quickly here. So I will go and deploy something really quickly. So let's say I want to make a new application, right? So let me go ahead and create an application. And creating an application is actually very straightforward with Shippa. So I want to make an application called, Hello.js for the meetup here. I'm actually going to deploy to another cluster really quickly, just to validate something. Basically, the only thing you need to do to deploy with Shippa is provide an image, right? Like this is as straightforward as it comes. So if I kind of come back to my trusty command here, as we go back to Docker Hub, we look at what the tag is. So if you haven't deployed something before, you can kind of take a look. See, you can take a look at the tag here, and you can say, "Oh, this is how I go about grabbing something." So I should look. Doesn't have the pull command here, but I know it by heart. So I will go and grab what we just created. And me finding on one screen, the Zoom stuff is like right over where I want to type. So let's see, hello, yes. We basically click deploy, and in a few moments, a few things will be done for us. And so like all I had to do was write an image, something like Shippa. So we will wait. So let's take a click in on what, excuse me, what actually got deployed. So it looks like it got deployed successfully. If we click into something like hello.js, automatically, Shippa has pre-wired a publicly accessible domain for us. Also, if you need to access like a internal service in Kubernetes status, but come and click here, just like that, a publicly accessible address, and we had hello Kubernetes. Now, clearly, this application, it's very simplistic. If you had a more advanced application or you had multiple services you need to deploy, that would be, another example, but it would still be fairly simple to do that with Shippa. I know that's pretty anticlimactic. Kind of one more piece I want to show you with Shippa is that, it's always very interesting to see like what all has been generated for you, right? Like if I were to kind of come in here and, let's say I wanted to take a look at like, hey, a cute, take a look at like, hey, what's actually running? Oops, cube, spell it. I'm on the wrong cluster, but if I wanted to kind of take a look at, hey, what was actually running, obviously to pick on something here, like, hey, I want to take a look at, what we would see is just a bunch of you know, particular Kubernetes information, right? Like as a developer, this would be quite confusing to me. It's like, oh, there's lots and lots and lots of infrastructure related pieces. Last little party trick, and we'll give it back to, you know, questions on Liam here, is that well, Shippa, you know, one of the things that we try to solve for is like, oh, let me try to visualize like what the developer's looking at. Like, hey, what are all the objects that kind of went on with Kubernetes in the back end that got created, or the applications using? I feel this is like fairly cool, like especially if someone you're using Kubernetes for the first time, saying, oh, like what are all these particular concepts that I had to deal with? And we will visualize that for you in Shippa. But kind of like in closing, in my part of the conversation here, is that, hey, you know what? It's fairly straightforward to go from building like creating an image from something that you've written in JavaScript using Docker commands, kind of spinning up a particular cluster, let it be with, you know, a cloud vendor, let it be in your local machine, and then finally using a tool like, you know, what we created here at Shippa to get that deployed and get, oh, I will move stuff around, to get access to your workload. You know, it's as simple as these like 9 or 12 characters say here. Without it, it would have been quite a chore, but hopefully that was informational, educational. Happy to answer any questions. Also, I mean, it could be about anything, you know, containery, Kubernetes, distributed system related. Happy to take those questions. So thank you so much.
If anybody's having any difficulty trying to speak in the chat, can you just let me know? No? So Ravi, I do want to ask you something, because as I'm looking at Shippa, I'm trying to really kind of understand what the benefit is. I guess the idea behind Shippa is you eliminate having to set up all of your plumbing that is pretty much standard for standing up a Kubernetes cluster, and you just expose those things that you need to customize in this kind of a 9-step checklist.
Yeah, absolutely. Yeah, so like I'll you know, turn the Shippa hat on a little tighter here.
Yeah.
Pull it down a little tighter. So yeah, that's pretty straightforward. That's pretty accurate, right? Like, you know, once you have a cluster, kind of the going joke is like, if you spin up a Kubernetes cluster, like, what does it do? You know, it's like turning on the power like your laptop for the first time. You know, like what exactly? It's not really ready for you to use. You have to install a bunch of stuff. I'm like, oh, I need to install Office. I need to install the browser.
Right.
But flipping that, you know, taking the consumerism part out of it, like, oh, I need to, like, on Kubernetes, like, for it to be application ready, right? Like, it's kind of a term like, oh, I need to install monitoring. I need to install ways to manage traffic. I need to install a way to manage storage. Like, there's just a lot of plumbing, like, for the cluster itself, to the platform engineering aspect of it. Also, there's a lot of plumbing on, well, how do you get stuff on it? You know, it's like,
Yeah.
there, you know, like, again, like, throws my parents in a loop, like their MacBook Pro doesn't have a CD drive. How does my father install TurboTax? This is a real conversation we had a couple weeks ago. I'm like, go to intuit.com and download it. Like, huh? Like, you can do that. You know, but similar thing, like, how do you get stuff on it? You know? And so it's Shippa kind of makes that, right. It's like a 9-pronged English approach. Like, hey, what really makes sense for your application? And like, because the founders and I came from the dev space. Like, we have lengthy development backgrounds, and so it's like, oh, these are the 9 things that frustrated us
Yeah.
having to answer. So we kind of package it up pretty nicely for you. So that's spot on.
Yeah, so I think that's what you're getting at here, which is the benefit that comes out of something like this. If you're going to stand up a Kubernetes cluster, you kind of have to be an expert at it, right? You kind of have to be an expert at knowing what goes into the pod file, right? So you're dealing with Docker files on the one hand, because you've got to write your containers,
Yep.
your files to instantiate your containers. Then you have to write these pod files, and you have to kind of like segregate these different service components into their own little spaces, right? And that could become a fairly complicated thing when all you want to do is build an application.
Yeah, it could be very, very complicated. Like, it's so funny that even as a cheat, like at the, it's definitely a split brain problem. Like, the folks that write the app are usually the folks deploying the app, right? And so
Right.
it's like, it was a common topic we talked about today at DevOps Atlanta. It's like, well, how do we manage, like, it's always like, how do you manage a complexity? Like, it's one thing to write something, which I'm
Yeah.
biased towards because I'm a software engineer, versus like, oh, how do we, configure a system that we don't really know what the limitations are, and then
Right.
we're expected to do stuff, and it's like a, chicken or the egg type of problem. But yeah.
Yeah. If you have to deal with infrastructure and you're a dev, you don't want to deal with infrastructure, right?
Yeah.
That's kind of like where it stands, and you want tools that can help you make that simpler.
Yeah, I don't do infrastructure. I'm forced to. Sometimes I'm like,
Oh, Fred is asking, I know DevOps engineers that don't want to do infrastructure as well. Not asking, he's stating.
yeah.
So how do you use Shippa to figure out, like, oh, here's a container that got to get torn down? Because are you able to set thresholds with Shippa, utilization thresholds?
Yeah, mostly has to do with like auto scaling. And so like one of there's like very, very complicated auto scaling that you can do with Kubernetes. There's something called, like, so this is not what Shippa will cover. Like, there's
Okay.
certainly overkill. There's like 2 sets of duality. Like, what happens in like a very modern platform engineering team, and this is what I've seen over the last couple of years becoming the most popular model. Like, there are folks that are maintain cluster capacity, so they're the platform engineers. If we're working at a big bang, their platform engineering team is more focused on, do we have sufficient capacity and availability for someone who wants to put work on there,
Okay.
to be there. And so there's a lot of the scaling stuff focuses on that, like something called the cluster autoscaler and the HPA, the horizontal pod autoscaler, that are more focused on capacity related things in the cluster, not necessarily for your workload, right? Now with Shippa, we help wire very like easy auto scaling rules.
Okay.
Oh, if you need another replica based on like CPU is an easy one, right? Like, oh, if you get, reach 95%, get one more of what
So you guys
need.
are taking care of right now the low-hanging fruit on this.
Yeah, like very like simple low hanging fruit. Yeah.
Okay. All right. So if you're going to get into like really tuning things, that's when you're going to have to be a gearhead.
Yeah, it's like outside of like, it's more
Okay.
of the platform level. Yeah.
Sure. I understand. Thank you, Ravi. If there's anything else you want to add, go ahead.
Sure, yeah, I'm all set. Hey, thanks for everybody sticking on. Thanks for having me. Always great to talk. So yeah, see you.